Hello again. Today we learned about partial quotient division, and it's a little bit different than the normal strategy that we all grew up on and that we normally teach, the traditional long division. But this is an alternative method that we really found successful today, and so many of the children completely understood it while we were doing it. We just need some practice. So this is a review of our partial quotient division practice that we did today. So what we're going to do, anytime we divide, and this is what we've learned in class, anytime we divide a number, we're separating into smaller equal groups. When we find our divisor, we will write our multiples of that divisor. So I've only gone to 48 in this case because we are, again, just like we did when we used compatible numbers, we're going to look for the closest nearby multiple that gets us to or close to maybe the first or the first two digits in our dividend. So the closest nearby multiple that gets us close to 37 is 32. So that's what I'll use. We know that 8 goes into 37 several times. That'd be 4 times. So we'll write our 4 out to the side. This is different than what we grew up with, so that's why I'm creating this video. Our basic fact is 8 times 4 is 32. But if I want another 0, I can take out the maximum amount of groups. And we're looking at multiples of 8. 8 times 40 is 320. So I can take a huge chunk out. You know, in traditional division, we'd only be looking at 32 coming out, and we're just whittling it down. Well, we're just using a different way to whittle down our number. So we're taking 320 out of our 372. We still subtract like we always do with long division. 7 minus 2 is 5. We'd have 52 left over. So we've gotten rid of 320. We have 52 left over. So it's a new division problem. If we have 52, how many groups of 8 can we make? Well, I'll go ahead and add one more to our list. Do we have 56 to put into equal groups? No. But we do have 48. So again, we're just picking the closest nearby multiple. 8 times 6. We'll write our answer out here. 8 times 6 is 48. We just take that out, just like we normally would. We have 4 left over. So all we do is we say, okay, we're finished. We don't have anything left to divide out because 4 doesn't give us enough to make groups of 8. So we're finished. All we do now is add together these two answers. It's 46 with a remainder of 4. It's pretty interesting how this works. It's the inverse of an area model, and I'll show you that in just a minute. Okay, when we had area model with multiplication, here's what this would look like. If I turn this kind of sideways, this is what I did in class today. If I turn this sideways, if I think about what's inside this rectangle, so for instance, if I close this rectangle in, and I said, okay, let's think of area. Well, if I have 8 groups of 40, what do I have? In this part of my area model, I'd have 320, wouldn't I? Well, here is our area model. This is what I was able to put into this part of the division, 320. I was starting off with 372, so in this part I have 320. So I'm thinking 8 times 40 is 320. Well, that's what I have here. So here's what I have left. I have 52. Well, let's put into perspective what part of 52 I can put 8 groups of. So here, 8 times 6 gives me this 48, and so that's what I would have in this section of the area model. So I was showing the kids today how this is the opposite or inverse of an area model multiplication, because here we have 8 groups of 40 equals 320. That's what we were able to put into groups of our original number, original dividend. 8 groups of 6 is 48. So in a multiplication, what we do is we take our original, say we had 8 times 46. Well, we can take that apart into 40 and 6. Well, don't we have this number expanded? That's 46. So we end up with the opposite of the multiplication with an area model inside our division. But this time we have a remainder, so that would be kind of sticking out to the side. So I was trying to make that relationship with the kids so they can see that really this is exactly what we've been doing. We're just doing it in the reverse. So let's work some more problems, then I'll show you how this works. You might get the hang of it and think it's really cool. Our kids just really enjoyed it today. So here's another random number. We have 654 divided by 8. We'll pick 8 again. Okay, so we have 8, 16, 24, 32, 40, 48, 56, 64, and 72. Okay, so what I told them, let's go ahead and draw our line. The first thing we always do is if we're dividing by 8, let's count our 8s. It's good practice anyway. Well, if you know your 8s, if we look at our first 2 digits, we can see that 64 is the closest nearby multiple without going past. We do have enough to put 64 into groups, but we're going to make this number a little bit bigger. So let's go ahead and write 64, but we need to, out to this side, make sure we write our quotient, our partial quotient. It's not the whole thing, but it's partial. So 8 times what gives us 64? 8 times 8. And we want to make this number as big as possible as we need. So we'll add that extra place marker 0. So 8 times 8 is 64, but 8 times 80 is 640. So let's go ahead and subtract, just like we normally do in a long division problem. 4 minus 0 is 4. 5 minus 4 is 1. Gosh, we only have 14 left to deal with. So that's easy. We look down our multiples. We have 14 left to divide. How many equal groups of 8 can we make with 14? Only 1. We don't have enough to make 2 more groups. We only have enough for 1. So I'll go ahead and put my other part of my partial quotient here. 8 times 1 is 8. Let's take that out of the 14 that we had. 14 minus 8 is 5. So that's all we have left, 5. So that would be a remainder. We have 5. We cannot make another equal group of 8. So we just put these numbers back together. It's 81 with a remainder of 5. And again, this really is just like an area model in reverse. 8 times 80 is 640. That's what would be in this section of this area model. 8 times 1 is 8. That's what would be in this section of the model. And then we'd have 5 on the outside. If we put those numbers back together, we have 81 with a remainder of 5. Let's do another one that's not dividing by 8. And please feel free to pause the video if you want to work on it and see if you're correct. Go ahead and try to work it and see what happens. We'll do 753 divided by 4. Now these type of problems kind of stumped everyone today because usually we're looking at the first 2 digits, but let's look at this first digit. Can we fit 4 into 7? Or likewise, if I have 7, can I make groups of 4? Yes, I can. So please feel free to pause the video. If not, I'm going to keep going. So we have 4, 8, 12, 16, 20, 24, 28, 32, 36, and 40. Okay, well, some of the kids today were saying, well, gosh, you know, we'd have to count by 4s all the way up into the 70s. No, you don't have to do that. Let's think of number sense. Let's take a big chunk out of this. We know that if we have 7, the closest nearby multiple without going past is only 4. So let's go ahead and put a 4 right there. Well, how can we get 2 more place value positions? Just add 0. So what gives us 400? 4 times 1. It's 1 multiple, but 4 times 100 gives us 400. So let's take that big chunk out. So then we'd have 353. So that still seems like a big number, but that's easy to work with now because we use the same process we did up above. We have 35 is the multiple that we're looking for. 32 is the closest nearby multiple. So let's pick 32. 4 times what gives us 32? We have to write this out to the side. This is where our answer goes. 4 times 8 is 32. So 4 times 80 is 320. So that's a big chunk we're taking out. So that's 3, and that's 3. So now we have 33 left, whittling it down as we go. If you know your 4s, you know the closest nearby multiple is 32. So that's going to be very close. So we'll put 32 down here. You have to write your answer, though, your partial quotient, out to the side. 4 times 8, again, we're using that same fact. 4 times 8 is 32. We'd have 1 left over. So all we have to do is double check our remainder. Do we have enough to make another group of 4? No. Our remainder must be smaller than our divisor. So just put these back together. This would be 188 with a remainder of 1. Okay, let's try one more problem, and that's good for our review. So remember, pause the video when you need to and check your work afterward. Okay, the last one we'll do is 592, and we'll divide by, let's see, 6. Okay, so if we're dividing by 6, write your 6's. So again, pause the video and then check your work afterward if you want to give it a shot. 6, 12, 18, 24, 30, 36, 42, 48. That might be, no, we need to go further. 54. I think that's going to be good. Okay, let's look at the first digit. Well, if we have 5, can we make a group of 6? No, so we really do need to look at the first 2 digits there. So that's 59. The closest nearby multiple of 6 is going to be 54 because we don't have 60, do we? We don't have 60. We're not estimating right now. Can't do that. So 54 has to be the multiple we pick. So 6 times what gives us 54? 9. That's our basic fact. What we can do is put an extra 0. So that would be 6 times 90 is 540. Subtract as usual. Let's see what we have left. Well, we have 52 left. We can't use that fact. It's still a lot, but we have to go 1 beneath it. 48, we do have that. 6 times what is 48? 8. 6 times 8 is 48. Subtract what you were able to put into groups. 12 minus 8 is 4. 4 minus 4 is 0. I think we're finished. If we have 4 left over, can we make another group of 6? No. So we must have a good remainder. 90 plus 8 is 98 with a remainder of 4. Now I don't want to forget that you can check your work. We practiced this today also. Always check your division by multiplying back and adding the remainder after. So let's try it on this problem. 98 is our main part of our quotient. So 98 times 6. 8 times 6, that's the problem that we worked right here. 8 times 6 is 48. 9 times 6, that's the fact that we worked right here. 9 times 6 is 54 plus 4. My goodness, look what I did. 54 plus 4 is 58. Made a mistake. So let's add the 4 back and see what happens. So 8 plus 4 is 12. 8, 9. If we end up with the same dividend that we came up here, our original number is the same, then we're good to go. Great, we did. That's our lesson for today. If you need any more help, please feel free to contact me at any time. Bye. Have a good evening.